40 and 40.
Yeah, 4.6.
All right. So it's $185 a day plus 32 cents a mile. Yeah. That's for one thing. So RV rentals of Southern California. Oh my gosh. RVSC. Where'd they go? They rent $185 a day. And you're almost dead, poor little dude. Ah, let you go. And then 32, where'd you go? 32 cents per mile. And then the other place, Martin RV, $206 a day, 29 cents per mile. So on the surface of it, if you weren't going to drive very far, which one would you go with? Which one does it count against you if you go very far? Martin, right? No. This one, RVSC. So 32 cents a mile. So if I don't plan on going very far, I would take these guys because it's less per day, right? If I plan on going a long distance, very long distance, I'll go with these guys. Because you do save some money here, right? But do you start? So here's where the intuitive sense of slope. Believe it or not, this is all about slope, really. This one starts off costing more than this one. True? At some point, isn't this one going to catch this one? Yes, because it's going up faster than this one is. So it's like one starts up higher than the other one, but the other one is going up faster. So at some point, we're going to match up. Okay, I like it. So this asks probably where that happens.
Yes, that is what it's asking.
So that question makes sense, right?
It does.
No, I'm sorry.
I guess the basis of it is confusing.
So just the idea of what the problem is getting at
I'm
makes sense.
having a hard time making the problem.
Good. Let me see. Where'd you go? There you are. For what daily mileage is the cost the same? 11. So we got to set up equations for each of these. This is daily mileage. For what daily mileage? So the per day doesn't really mean anything. What's really changing is the amount of money I pay because of the distance I went. Right? And it asks you, in the question it says, for what
Daily
mileage? So of course, what should my variables be? That's right. Well, doesn't really matter. So I'm going to say R is the miles for RVSC, right? Actually, this is kind of silly. I don't need to even get anywhere near that specific. I'm going to say that X is the miles driven. This isn't even a two-variable situation. So I have a set distance to travel, right? Just because I pick one or the other doesn't mean I'm going to travel further. Let's say they're right next to each other, right? How much are you going to pay for this guy if I go 10 miles, for example? If I went 10 miles, how much would I pay for this guy total?
32 point, would it be 0.32 cents in cents?
Well, it says 32 cents per mile, so if I went 10, let's go 100 miles. Let's go 100 miles. If I went 100 miles, how much money would I pay just for the mileage? 32 bucks. Is that cool? 0.32 times 100. Because it's a good pickup, right? That's in money. It's in dollars. This better be in dollars, too. So really, I should write this as $0.32 and $0.29. So all my units match up. Can't add like 7 feet plus 1 inch. Is 8 foot inches? No, you need all the units to be the same. So what if it was, so I'd be 32 plus 185. It's always plus 185, right? It's 185 just to get in the freaking thing. And then however far I go, I got to pay that much. I like it. So it'd be 185. So for this guy, it's 185 plus,
$32?
well, that's if X was 10. I'm sorry, 100. If I went 100 miles, I would pay 32 extra dollars. What if I went 200 miles? 64.
Oh, plus 0.32x?
Yes, plus 0.32x. 32 cents per mile. And you're going to set that equal to the other dude. Well, once you got this dude set up, the other one's the same thing. Just with his money there, right? So the other guy's going to be 206 plus
0.29x.
0.29x. And then you solve for x. If you solve for x, you're going to find out that place that I had here earlier where they meet, where the price would be the same for both. If you went further than that after that, it'd be better to take this guy. If you didn't go that far, it'd be better to take this guy. I don't know, there was a gym in North Park. I used to live in North Park. There's North Park Fitness, what a name for a gym in North Park. And they had these different levels of membership, and it really depended on how long you thought you were going to live there, because the shorter one cost less money per month, but more up front, or something like that. You see what I'm saying? You see this kind of thing all the time, and being able to rationalize which one's better. Like, are you going to buy, I don't know how it is for the bus anymore, to be honest, but you used to be able to buy like a book, like a thing worth for a month, or you could buy each day, each time. And once you got a certain number of days, it would have been smarter to get the book. That's the same idea. Because one slope is bigger than the other one. It's better down here for this guy, but then, oh shit, after that, this guy is better. Does that feel familiar? So now this is giving you better tools to really see where is that point where it's better to do this way or that way.
It's like the parking at school. It's better to buy a permit than spending $2 a day.
Yes, I love it. Beautiful. If you're only going to come to class so many days a month, then it's better to buy it each time. Or if you're going to go over a certain number of days, might as well get a freaking pass, right? Or, park in the neighborhood for free and walk a little bit, like I used to do. And some guy's like, really? Walk. Nobody walks in California. Anything else from homework stuff? Anything? Yeah. 9.3. Oh, is Bria selling her dried fruit mixture? Right, that's the one?
Yeah.
So she's got... Alright, so let me see if I can do this. Okay. Dried fruit mixture, that sounds so yummy. $5.80 a pound. Hawaiian macadamia nuts, $14.75 a pound. There we go, $14.75. Dude, yeah, those macadamia nuts. Jeez. She wants to blend the two to get a 15-pound mixture. 15 pounds. Where'd you go? There you are. Sell for $9.38 per pound. Now think about it like this. If I have a bag of these, and I start pouring these in, what will happen to the price? So I got a bag of these, like here's an empty bag. I got a bag of these guys. I pour them in there. And then I start pouring these guys in. What's going to happen to the price? The overall price. It's this, and as I pour more of these in, what happens? It's going to go up. The price is going to go up. Are you kind of with me? It's sort of like diluting something, or, right? If you have pure alcohol and you pour water in, then it's going to become less and less alcohol. So if you have something that costs this much money and you start pouring this in, it's going to go towards a mixture of the two. Right? The more of this you got, the cheaper it is. The more of this you got, the more expensive it is. How we doing? All right. Okay. So, all right. So again, there's two levels to this. There's just you understand what's really happening here. Does it make sense that this is $9.38 a pound? Yes, because that price is between the two. Any mixture is going to cost somewhere between these two. Pure this, this. Pure this, this. Mixture in between. Let that make sense, right? Okay, now let's bring the math in.
What section of numbers?
This is section 9.3.
Number 23.
23, yeah. So 9.3 is the one where they introduced matrices. This is the section with two variables happening, right? So what are my two variables? Actually, 2 or 3, I think, in this section. What are my variables going to be? What is it that I don't know?
How many nuts of each and how many fruit?
Yeah, how many pounds of each, right? I don't want to end up with 15. Doesn't that give me a really easy formula,
Yes.
right? So if I call D my dried fruit pounds, and I call, unbelievably enough, M my macadamia nuts, right? You with me? The pounds of macadamia nuts. What's the easy equation I can set up?
D plus M equals 15.
D plus M is freaking 15. Okay, that much I know. Can anybody tell me, anybody know which one there's going to be more of? This is a neat question to ask. Before I do any math, can you tell which one there's going to be more of?
The dried fruit,
Why?
because it costs less.
Well, I mean, you have to know.
It's closer to.
It's closer to
the number
this.
than the other one.
Yeah. If I use equal amounts of each, then the end price per pound should be the average of these two. Does that make sense? If I use more of this one, then the price should be less than the average of the two, and that's what that is. That's closer to this than it is to this. Do you have to know that going in? No. So why does Jeff do this shit? To try to make math more immediate instead of A and B and the plus? No, I mean, it has to make physical sense. So the second equation has got to bring in what idea?
Price.
Price. What's the total price for the amount of dried fruit I got? I know I got D pounds of it.
$5.80.
For every pound, so how much total money? How many pounds of it do I have? We know exactly. We know. That many pounds. No, we don't know we have 15 pounds of dried fruit.
So it's 580 D.
Yeah, so it's 580 D. Is that cool?
Yeah.
580 per pound of dried fruit. Plus, how much money do I get for the macadamia part?
$14.75.
1475 M. Now here's the tricky part. Do you see how this is price per pound times pounds? Price per pound times pounds. So what's the other side got to be? Price per pound times pounds is going to be the total. So what's the price per pound for the total? $9.38 times 15. That's really easy to forget that guy right there. It's got to be complete cost equals total complete cost. So it's really easy to forget this guy right there. And of course, it's really easy not to have a clue what the hell I just did, but hopefully. One idea was straight up total pounds. The other day has got to bring in the price. And people get to that point, but then they forget I multiplied price per pound times pounds, price per pound. The other side's got to be the same idea, or the equation doesn't make physical sense.
What do you have in parentheses that I asked her?
Say again? Sorry?
What do you have in the parentheses that denote this?
15.
Oh yeah, I got all. I got like a John Madden kind of. Then you roll around here and say, then the defender comes in. Ah. I don't know if you guys know who John Madden is anymore. They still call it Madden football, right? Don't say of course, because there's people in here that have no idea. All right, and then from here you can do whatever. You can do substitution, you can do elimination. This is officially the matrix section, so they really do want you to do a matrix. But
Have fun.
What would that matrix look like?
1 plus 1.
1 0 is
1, 1,
0.
15. I know you want a 0 in there. You're going to have to work for it. And then
580.
5.8, 14.75, and then whatever the hell that is. I don't know. What is that? 419 times 30. 290 times 3. 125, 70? No, I don't know. What is it?
140.
Damn. 140, 70? Okay. And now this isn't that bad, right? You got all kinds of ones. So that you can kill him, release, bam, he's dead, make it 0, yay. That won't be as bad as it could be. Is my hope. Anything else from homework stuff? Yes.
9.2, number 9.
Oh yeah, all right. So this is the 3 variable problem. And let me see if I can set up one situation for this. So number 9 is the one that says, most nutritionists now agree that a healthy adult diet should include blah, blah, blah fiber. A breakfast of 2 bran muffins, 1 banana, and a cup serving of Wheaties contains 9 grams of fiber. A breakfast of 1 bran muffin, 2 bananas, and 1 cup serving of Wheaties contains 10.5. Do you see how each one I'm saying is a equation, right? Sort of like that very first one we did with like 4 pencils and 1 eraser cost. Remember that problem? It was 4p plus 1e. So you just got to identify the 3 variables you're going to use. The amount of fiber in a bran muffin. What do you want to call that? I'm going to call it M, because the next thing is freaking bananas. What the hell's their problem? V, you can call it Y for yellow thing, I don't know. And then Wheaties, yeah. 1 cup of Wheaties. Get out of here. Done. A cup of Wheaties. No. We don't want 4 variables. So 2 bran muffins, 1 banana, I think. Yeah, 1 banana. And where are we at? 1 cup serving of Wheaties gives you 9 grams of fiber. That's all I'm going to do, right? Then you go to the next sentence, make the next equation, go to the next sentence, make the next equation, then do stuff. This is from the section before you knew matrices. So if somehow magically you love matrices, you can't use them in 9.2, right? I think so, right? Yeah. Okay. You guys, is that cool? Yes? There's no bacon in there, so I don't officially recognize it as breakfast.
Never heard of Wheaties before.
You've never heard of Wheaties? You guys heard of Wheaties?
No.
It's like all the athletes.
Oh, yes, famous for having athletes on the cover.
Oh, the protein thing?
Yes.
Oh,
Cereal.
okay, I know
Yes.
that.
Yes. I know. Some of you guys are like, is that from the 20s? Wheaties. A bowl of wheat. Is that what it is?
Yeah, it's not even that good.
Huh?
It's not even that good.
No, it's not. No. That's why you haven't heard of it, because it's not good. Right. All right, anything else? Yes.
Can we do number 15 and 1?
All right, so I'll tell you this. That one has a weird answer.
Yeah, I know the answer. I know what the answer is, I just don't understand how to get there.
How do you know what the answer is?
Because I looked at the back
Okay.
and I seen that there was no solution, but
So what that means, how do you arrive at a no solution answer? What is going to end up when you have a system of equations?
a 0?
Well, maybe.
No, I'm looking at it.
You could either end up with 0 equals 7, or you could end up with y equals 2 from doing stuff, and then y equals -1 from doing some other stuff.
Okay, so never mind, I did it right.
Yeah.
I did get that.
Yeah. Those are the two main ways. Either you get that, which we know how to interpret this, no solution. Or, depending on the way you did it, you could end up with y is 2 in one case and y is negative 1, and that can't be true. Yes, no, maybe? Okay. Do you have a question here?
For 50.
And,
You'll still not want to go 50.
For 50?
Ooh, 50. Did I really assign that one?
No.
Were you just looking at it?
Yeah.
So, just to say, because you asked, remember I told you if I had 4 variables? You'd have to pick a variable and kill it 3 times, right? So if I have W, X, Y, Z, and I have 4 of those, if I pick W and kill it 3 times, now I have 3 X, Y, Z, X, Y, Z, X, Y, Z's. And how do I do that? Well, the way that we do any of these. So whenever you add another variable, you add another layer of killing, right? So if I had 5 variables, I'd kill one variable 4 times, and then kill one of those remaining variables 3 times, and then I kill one variable twice, and then I do the whatever I want to.
So it's just adding more to it. Just adding more to it.
Yeah, exactly. And that's why matrices make that so much easier, right? If I did that with a matrix, it wouldn't be much harder than a 3x3 matrix.
Yes.
Yeah. But in 9.1, you're not allowed to use matrix. I don't think I assigned that.
No.
That would be like a bonus question I would do. All right, anything else? Okay, so let's get back where we were. I'll need this one. I think we got this far last time. We got, like x. What's x to the a times x to the b? I don't know why I'm saying a lot like that. X to the a plus b. Right? What do you do when you multiply like bases? You add the powers. For example, m squared times m to the 9th would be m to the 11th. It's crazy. Why does it make sense? What is that? What is that? So then how many m's do you end up with in a row? 11. So that's just really just linking these two chains together so you end up with one that has 11 things. Right? I like it. And of course, this is where I get to say my famous, there is no 9 anywhere in this thing. There's no 9. There isn't. There's 9 m's, but there's no 9 in here anywhere. So don't say 2 times 9 is 18. That makes no sense. There is no 9. Why would you multiply by 9? Okay, you're just saying a couple m's, 9 more m's, 11 m's. That's all you're saying. What about then if I divided 2 things?
So,
And 7.
Subtract, I like it. Kick ass. Kind of the inverse, it makes sense. Here you're gaining more m's, here you're losing a couple m's. I like it. Then we did, I think the next thing we did was m to the 0. This is 1. I like it. And we kind of proved it. I mean, m squared over m squared would be m to the 0, right? 2 minus 2 is 0. But something divided by itself is 1. I like it. Or you can look at it, when I multiply m to the 0 times m to the 9, I get m to the 0 plus 9. 9. So what did this really do to this? Nothing. What's the only thing I multiply by that does nothing to it? 1. So there's 2 different ways to look at why m to the 0, anything to the 0 power is 1. It's weird? Watch this. This is kind of cool. So I have a 1 sitting here. And what's 1 times x? X. And what's 1 times x times x? And what's 1 times x times x times x? So if I divide by x, I get x squared. If I divide by x, I get x to the first. If I divide by x, I get x to the 0. If I divide all the x's away, what's the only thing left? That understood 1. That's why if there's no freaking m's, what's the only thing there? The understood 1. It's just always been there for us. Aw. It's always there. and it only shows up when everybody else is dead. It's like I'm here. Oh, sorry, I get emotional in that response. Now I think we didn't do this next one yet. What in all of shit would that be? Some of you guys might know already. Would hope, yes, but why? Well, let's do the same thing we did here. What would I put under here so the answer would come out to be -1 up there? No, 2 minus -2 is 4. 2 minus -3 is 5. I need, what do I subtract from 2 and get -1? Yes, all right. Right, 2 minus 3 is -1. Now, stay with me. Is that cool? You guys with me? So I'm investigating it the same way I did with this sucker. Trying to use properties I already know to investigate something I don't. How can I write this? Like that, Jeff? Okay. And then what cancels?
The 2 on top and 2 on the bottom.
And what's left?
1 that's
Where?
on the bottom.
There you go. That's why x to the -1 is 1 over x. This is kind of like I owe an x. So x times x is x squared. So x to the -1 is like I need an x just to become 1. I owe an x. No? You don't like that? So help me out. What's x to the 8th divided by x to the 1st?
X to the -7.
Come on now. X to the 7th,
7.
right? Don't freak out. What's x to the 8th times x to the -1? What do you do with the powers? Adam, what's 8 plus -1? 7. So this must be the same as this because I got the same answer. They must be the same as each other, right? If A times B equals A times C, then B frickin' equals C. You guys kind of with me a little bit? So all a negative power means, the only thing it can do is flip what it's sitting on. So let's play with this for a little bit. Negative powers get freaky. So let's see. X to the -1 equals 1 over x. So let's do some examples. What would m to the -2 be? What am I doing to the m? Flipping it and then squaring it. So it'll be, let me just write it. What you guys think about it? X to the -1 was 1 over x to the 1. M to the -2 is 1 over m squared. How many m's would I lose if I multiplied some number of m's by this? So if I have m to the 10th times m to the -2, what's the answer? You lose 2 of them, right? So you get m to the 8th. Come on, stay with me. Come on. So effectively, this guy does the same job as this guy does, right? What happens here? You lose 2 m's, m to the 8th. So you see how losing 2 m's, this will make 2 m's disappear. That's why they are the same. I'm going to lose 2. What's the other way you lose 2? Divide by 2 of them. Then you lose 2 of them, don't you?
So you're saying m to the -2 is kind of like indicative of anything over m squared.
Yes. So
Like 10.
if I had 3m to the -2, that would be 3 over,
M
yeah. I like it. You guys don't, that's okay. Yes?
So, if it's like the m to the 10 times m to the -2, we just put it into the division?
Of course you could. Yes, they mean the same thing. So if I had a problem like x to the 8th times x to the -5, I can write that like this. No. If it makes more sense to you, but to be honest, what would you do here? 8 minus 5 is 3. What would you do here? 8 minus 5. Do you see how that property of dividing means subtract powers? So if the power itself is negative, it's as if it's being divided. So this whole idea of flipping it makes complete sense. It's my hope. You guys all right? You guys
I mean, like, are we about to see why you would want to do that?
Huh?
Why you would want to flip it like that?
It's just what it means.
Okay.
That's the thing to realize. So, what this is eventually going to lead into, let me see if I say this and see how many people react, is scientific notation.
Yeah.
Scientific notation. Okay, I like it. That's one of the most immediate uses of it. But if I said something like, they were 10 to the negative 42 feet apart, is that far apart or close? What is 10 to the negative 42? It's 1 over 10 to the 42. Well, 1 over 10 is 0.1. 0.1 feet's pretty close. So this is like 1 over 1 followed by 42 zeros. So what am I most likely talking about? Like parts of an atom or something, right? They were this close. Holy shit, you're not talking about people. I mean, right? You're a little gross. You kind of with me? I know. I have strange examples. But that's how I think about it. Okay. Let me see. Oh, so what about this? Here we go. The important thing to realize is that the idea of a negative power is flip. The idea of a negative power is flip. Yes. Do those 5 X's like it down there? Do they like it down there? No. They're negative. They hate that shit. That's the bad YouTube comments. Your video's dumb. But if they come up here, now they like it up there. They're going to be happy up there. That's really the most immediate usefulness of it, to be honest. I mean, that looks a lot better than that, doesn't it? Yeah. I like it. Maybe. So be really careful, though. I mean, I think you guys have seen this already. You try to do multiple things at you at once, just to be evil. Yeah, sure. I like it. What's the only thing that wants to move in this problem? Yes, the thing with the negative power. Everybody else is cool where they are. So will the 4 move down?
No.
Why would it? What power is understood to be on the 4?
No. Or X to the negative, right?
What power is understood to be on the 4?
Oh, 1.
1. Positive 1. Why would it go anywhere? So we're going to have problems with more shit in them. And my first step to tell you is find the negative powers, flip them. If it's up top, put it down. If it's down, put them up. Get rid of all the negative stuff. Right? So how do I rewrite this? Those 5 go down. So I end up with how many X's down there?
7.
Beautiful.
And is that going to be written 4x to the 7? Like
No.
if we did it over there?
It could be, but it's convention to end up with no negative powers. What is another way I could write this? Because to be honest, I could have brought them up instead.
That's what I know.
I know,